Hello, I'm Jeff Stewart from Goddard Space Flight Center in Greenbelt, Maryland. The Deputy Project Manager, one of them that's on the program for Composite Crew Module. We've had a lot of fun with this project. It's somewhat different than what we usually do at Goddard Space Flight Center, so it's been a lot of fun melding experiences and everything from people from across the agency and industry. Like we were really forming in this team. Generally, we have spacecraft teams that really work, people that we've known, we've worked together for years. This was a chance to get together with people across the agency where we didn't know anyone at the beginning. There's certain challenges there, but certain great benefits because you share all kinds of different ideas that you'd never thought of before. So really had two functions on the program, Deputy Project Manager, but then also I was Design Engineering Lead. And what the Design Engineering Lead's role was in this case was to really start off with the first co-location we had at Goddard Space Flight Center, where we had our team coming together from all across the country, was to go into brainstorming sessions and really decide what we were going to create. We knew it was a composite crew module, but there were many, many variables that were still open to us as to what that design would entail or what it would be. We ended up taking probably the first week or so of our team's experience together going through that, and then quickly had to come down and nail down some requirements of what the design would be. And the reason for that was we had an 18-month time period in which we were supposed to originally have this unit built, not tested, but at least have it designed and analyzed and manufactured, which was a very challenging goal for us. Especially like I mentioned already that we hadn't worked together before, so we didn't really know each other's skills, but here we were going to go ahead and design this full-scale article and come up with that kind of an experience in a test article. What we did after the brainstorming session, really, we came down with certain designs and came down with a real ultimate goal of what we were after. So then we knew we had to break it down and try to really figure how our team was going to work to attack that problem, if you will. You know, instead of having one portion just thrown over the fence for one group to work on, we really took our whole organizational tree, and if you look across our project, we have people from each group, like the analysis folks or analysts. They have people from Northrop Grumman, from Genesis, from Goddard Space Flight Center, from all over. Basically, we had each discipline had people from each sector, if you will. So that way we ended up combining a lot of ideas and everything and getting the best that we could really come together with. So anyway, we basically got a set of requirements. We knew Orion was changing rapidly with their requirements, but in order for us to be able to build this thing in 18 months, we really had to anchor down and draw a line in the sand, get those requirements nailed down and not change them, because we'd never be able to build it in the time allotted. So we drew a line in the sand, started work analyzing and designing, coming up with test bed materials for the manufacturing group to go build and for us to test, as well as one of the items that we were most worried about was the tooling necessary to produce this full-scale article and how long that might take. So the real thing that we were going after there was come up with a full-scale tooling. We went to many vendors, realized that there were a couple really good companies out there for full-scale tooling, so we were again meeting with those different folks and finding out what they can and can't do in order to establish a good set of requirements that would allow us to go and make this thing and do it right the first time. So along with that, you know, our team was at this point starting to meld together more, understanding who could do what, divide up the labor and get our tools together, get in sync on our tools. For instance, the computer-aided drafting or CAD tools that we primarily used Pro-E, except for one entity was using CATIA. So we had to make sure we could work with that and trade models and so forth. And then similarly on the analytical side, we had Nastran and Patran, FEMAP, but we also had Hypersizer. We had Craig Collier's company, Hypersizer, in with us, and we wanted to be able to best utilize each of these tools and come up with a really good way to analyze and know what we had. So people who had never used Hypersizer before, you know, Craig did a good job of working with them and bringing them up to speed, and everybody working together on what can and cannot be done. So a lot of effort there, and just getting everybody in sync on the tools. Really, in both roles that I was involved in on this program, certain skills definitely float to the top, if you will, as being important. One of those is effective communication. Another is team building. You know, in school you may be taking a class where you have to work with other people and you're thinking, why can't I just do this by myself? And in fact, you know, it might be a lot easier for you to do it by yourself, is what you think. However, what we end up with in a team like this is the idea exchange and be able to bounce things off of each other. So there's so much to gain by working as a team. There's always, you know, the old adage that two heads are better than one. Well, when we have a 30-person team quickly running out there trying to come up with a design, it really works to our benefit to share those ideas and experiences that other people have had. Not always is that easy. One thing I love doing, and I guess part of the job, is being a coach, right? And I had a lot of experience growing up as a coach from the time I was 16. That really helped with this and has helped me through my career. Being able to take people from different walks of life and understand how they might be approaching it different than I am and different than the other people on the team, trying to relate that to one another and smooth out miscommunication, getting people working harmoniously. All that's key to being able to have an effective team. I mean, we had mechanic ways of doing that too, with different ways of communication with IM and WebEx, and ways to stay involved and together even though we're, you know, 3,000 miles apart or whatever across the country. There was that aspect, but there was also the aspects of really working as a team and making sure we're having fun doing this, that it wasn't just a knock-down, drag-out process. You know, so all those kind of things where we'd have nights, even though we'd work long into the night, weekends and everything, in order to achieve what we needed to achieve quick enough. We'd also take breaks every now and then, go bowling or skeet shooting or do different events together as a team. And that really solidified the bonds between us and really helped us get through the tougher hurdles that we encountered. Again, that just seemed to be a very crucial part of our being able to meld our experiences together and come together as a team. The composite crew module itself is much different than the spacecraft we typically do at Goddard Space Flight Center. What we usually do are non-manned missions, and so we have robotic spacecraft that don't require humans involved. So parts of Goddard do work on things like that, but the ones I've been involved with the most, at least, didn't. What this allowed us to do was really concentrate on a complex shape with composites, where most of the ones we've done before are more like optical benches that are flat face sheet type honeycomb structures or tube gusseted structures out of composites. So this provided us a unique opportunity that way to learn a lot about the way we would construct structures that have 3D complex curvature shapes to them. The chance to work with other folks here in industry where they've built aircraft, for instance, that have a lot of this, and meld the skills of those kind of folks into our team was a real benefit to us and really helped us. One thing that always inspired me really is being able to take a challenge or a set of requirements and make it come into real hardware. For me, I don't really enjoy paper studies. What I love is getting my hands dirty, working, building something, and really seeing the fruits of our labor. And seeing the fruits of our labor, when I say our labor, I mean our team, rather than just me building it. So for me, it's all about the team and what we can accomplish together. So again, the communication and the skills involved in that, and just the laughs you have along the way, and the fun you have, and what you achieve. Here's a giant full-scale composite crew module that we were able to build in a short period of time with people we never knew. That was very satisfying to me.